just want to look at an introduction to linear versus quadratic equations. Before we get into all the techniques of solving quadratic equations, I think it's really important to think about what you've learned in your past and how quadratic equations are similar and how they're different. So right now you guys are getting ready to really dive into quadratic equations, all different types of quadratic equations. And most of your past has been spent on linear equations. For example, a linear equation in one variable might look something like 3 times the quantity x plus 2 equals 7x minus 4. All right, the one variable here is x. And the way you solve this after you simplify each side, the strategy is to get all your x's on one side by doing something like this. And then getting all of your constant terms on the other side of the equal sign and dividing, and you get an answer. 2.5, I believe that is. Okay, that's the strategy. You've been doing that so many times. It should be second nature to you. Get all your x's on one side, all your numbers on the other, and you're good to go. Okay? Quadratic equations are not going to be like that. There's a totally different strategy, and you need to approach it in a totally different way. You need to look at that like it was a cat or a dog. You know, linear equations are like cats. How do I take care of cats? I make sure they have a litter box. I leave them alone. Quadratic equations are like dogs. How do I take care of a dog? I got to take it outside every 3 hours. I got to, you know, play with it. And although you can play with cats too, but you get my idea, right? They're kind of the same because they're both equations, but they're totally different in the way that you handle them. Now, you do know how to do one type of quadratic equation in one variable. Let me give you an example. Let's say you have something like x squared plus 7x plus 10 equals 0. All right, you should know how to solve that, hopefully, because we've covered it. What makes this quadratic, first of all? Let's not lose sight of that. Let's write this up here. A quadratic equation in one variable can be put in the form ax squared plus bx plus c equals 0, a not equal to 0. Because if a was equal to 0, we would get a linear equation. We would get something like bx plus c equals 0, something that can be put in that form. It doesn't have to look exactly like that, but it can be put in that form. For example, down here, when I got to 10 equals 4x, if I would have subtracted the 4x to the other side, I would have had negative 4x plus 10 equals 0, which is this form. That makes it a linear equation. All right, so the first technique that you guys have learned to solve quadratic equations is factoring. Now, in order to factor it, you have to set it equal to 0. That is totally different than what you do with linear equations. You don't set linear equations to 0. You get your x's on one side, you get your numbers on the other. Quadratic equations, you get everything on one side, so the other side can be 0. Okay? Now, if you're lucky, it's going to factor. If it doesn't factor, we're going to learn another technique in the next video on how to handle that. Okay? So here this one factors to x plus 5 and x plus 2. Now, if I have two numbers that multiply together to be 0, either the first number has to be 0 or the second number has to be 0. And then I can solve these little equations. These are little linear equations, ironically. All right, so we get x equals negative 5, x equals negative 2. And those are my two answers. So another difference with quadratic equations is you could get two answers. Linear, you only get one. All right, big difference. I really want to emphasize when you're looking at an equation, the first thing you should ask yourself is, what kind of an equation is this? Is it a linear equation? Is it a quadratic equation? Is it a radical equation? Because depending on what kind of equation it is, that's going to determine how you move forward to solve the equation. There are different techniques to solve different types of equations. And quadratic equations have multiple techniques. Factoring is one of those techniques. And we'll learn more, like I said, later. Now, a linear equation in two variables is going to look something like this. Y equals 3 times x minus 1. Now I have two variables. I have x and y. Now when I graph a linear equation in two variables, what do I get? Well, it's a linear equation, so guess what you get? You get a line. Let's see if we can pull up decimals here real quick and make this work. Over here. All right, so if I graph y equals 3x, what did I say, minus 1? I get a line, and we get to talk about things like slope and y-intercept. The y-intercept is -1. The slope is 3, which means this is going to go up 3 over 1. Up 3 over 1. Linear equations are going to graph lines. You're going to talk about slope. You're going to talk about y-intercept. It's got all these characteristics. All right? Like your cat's needs and techniques to deal with cats, right? This is lines. Quadratic equations are going to look like y equals something. Let's do something like x squared plus, well, let's just do x squared plus 7x plus 10. Let's do that one because we had that. So if it's in two variables, what happens is instead of a 0 here, you have a y. If instead of a 0 here, you have a y, all right? And then you're going to graph that. Now, you've done a little graphing with these, and the graphing that you've done so far has basically involved making a table and plugging in numbers for x and then trying to figure out what y is. Now, we're going to learn some techniques to make graphing a little bit faster coming up here, but the main thing I want you to think about is when I have a quadratic equation, something that's in this form, x squared, what kind of picture are you going to get? Do you remember? Let's go take a look over here. Let's see. We have y equals x squared plus 7x plus 10. What did I do wrong? Plus 10. What do we get? We don't get a line anymore. We get a completely different shape. We get a parabola. It's a completely different animal when we have a quadratic equation. So anytime you see something in this form, you're going to get this shape called a parabola. That is what it looks like, okay? Just like a dog looks like a dog and a cat looks like a cat. You should be able to look at it and tell whether it's a dog or a cat. You look at an equation like this, that's a dog. You look at an equation like this, that's a cat. You know what to, right? They're different. You can distinguish them from their equation. Now, there's different kinds of dogs and different kinds of cats, and parabolas can go up, they can go down, they can be wide, they can be skinny, and we're going to talk about, how to tell whether they're wide or skinny or up or down from the equation coming up later. One thing I do want to point out to you right now, since we have this graph, let's say I was doing a table. Let me see if I can erase this here. Let's say I was doing a table and I let y be 0, okay? Now, think about where that would be on the graph. Let's go look at this graph again. Y is 0, okay? Let's go look at the graph. Here we go. Where is y equal to 0 on this blue graph? We're looking at this quadratic graph. Where's y equal to 0? Right there and right there. That's where y is equal to 0. Those are the x-intercepts. Let's go back and look at the equation in one variable that we just solved right here. If I let y equal to 0 in this equation, I would get 0 equals x squared plus 7x plus 10. And if I solved this equation, exactly like I did right there, I would get x equals -2 and x equals -5. So that means if y is 0, x could be -2 or x could be 5. That's giving me those 2 points, and those are two very special points. Those are called the x-intercepts. So the x-intercepts of the parabola right here, -5 and -2, you can find by setting y equal to 0 and then solving that equation. So there is a link between solving the equation in one variable and the equation in two variables. All right, so that's a little introduction. Really focus on when you're studying the difference between linear and quadratic equations. And in the next video, we're going to look at how do I solve a quadratic equation if it doesn't factor.